Okay, we're rolling here. So this is the first of many videos that I'll be making for you. Today what I want to do is go over two main things, and we'll review some of this in class. The two things are distributions and central tendency. Distributions are what we did in class last week when we looked at how to make a histogram. So this is an example of a histogram right here. And then that right there is just sort of an idealized distribution. In distributions, what we're doing is we're basically looking at where the individuals in our sample fall on the number line. What are the most common scores? What are least common? Things like that. There are several that are very, very common, and they have specific names, and we'll need to be able to spot them because they have a big effect on how we analyze data later. First of all, these two things here are called normal distributions. Other things that you might hear about are normal curve, because that's a curve, it's normal, or the bell curve, meaning that's shaped like a weird bell, I think. Anyway, what makes these guys normal distributions is that they are clustered in the center. So most of the people are in the middle. They decline on both sides, not just one side. And it's more or less symmetrical. Now, this guy is generated by an equation, so it's perfectly symmetrical. But this is what it looks like in real life. And you can see it's not exactly symmetrical, but there's some theoretical reasons why we can be pretty flexible and say, yeah, that looks normal-ish. And we can just kind of run with it. All right, so that's your first distribution. I showed that one first because it's actually my favorite distribution. When I look at my histograms, that's what I'm looking for. I usually want to see that because I can do a lot if I have a normal distribution. There are other distributions. This one here, this slide shows what we call the skewed distributions. So a skew in terms of graphs means that this is called a tail. There's a tail that extends in one direction but not in the other. And this is called negatively skewed because it goes to the negative direction. That is, the skew is negative or less than the body, the main part of it right there. And this one is just a positive skew because it goes in the positive direction relative to the body. So those are two different shapes. They're both skewed, but it's important to distinguish between positive and negative. Now, I want to look at this graph right here, because I want you to think about why some things are skewed instead of normal. Well, let's imagine that this is a set of grades for a class, and I'm going to move my little window here. Imagine that's a grade book from class. What you should see here is that we have a negative skewed distribution. And it's negative because nobody in this class can go over 100%. That's the highest score there is. And in addition to that, a lot of people got really close to it. So I would say that's probably a very easy test, and this ceiling right here is causing the graph to be negatively skewed rather than normal. So a lot of times that's the case where you would probably get a normal distribution if there wasn't something cutting it off. Like the highest possible grade here. I'll show another example. This is the annual yearly income in thousands of dollars, I think, in the United States. What you should see is that this is a positive skew. It goes up, comes down this direction a long way, but it can't go below zero. That's because there's no such thing as a negative income. You can go into debt, but that's a different concept altogether. So here what you have is a floor effect where you can't go below a certain point. And if there wasn't a floor there, well, this might turn out to be normal, but there is a floor, and so it's positively skewed. Floor in this case is $0. All right, so those are the main distributions that we will be looking for. Again, the normal is my favorite. That's kind of what I'm looking for in most cases when I look at a histogram. But it's very important to notice if it is a skewed distribution for reasons we'll talk about in a little bit. All right. I just went and got some pictures of things that I thought were cool because I wanted to see what central tendency is really about. So this staircase, if you look at the steps, can you see the normal distribution? Okay, I spent way too much time on this, but there we go. All right. So what you should see here is that these steps are actually a normal distribution. What they tell us is if a person is going to put their foot on one of these steps, they are most likely to do it right there in the middle. They are least likely to do it out on the sides. That's all the normal distribution is telling us. You're most likely to find things here, less likely to find things there. As I was looking upstairs, I found this one. This is kind of interesting because this one is a bimodal distribution. This one has two normal curves where the other one just had one big one. And to me, I think that what that means is that there are frequently people going up and down these stairs at the same time. And so in order for me to know where is it most likely that a person is going to step, I need to know if they're going to go up or down. And that gives me an idea of central tendency. We'll flip that over so you can see that. Here's one more set of stairs. The central tendency here, notice that the center is way over to the side. People are walking over here more, it looks like. So if I want to know where people are walking, see my distribution is skewed heavily so that the most likely places they stand are over here. Now, you can see that is a skewed distribution. I think the reason for that is probably because the stairs here are give you more room to stand, whereas up here the stairs are probably really skinny. So that's why these are the typical places for people to stand. All right, so those are just some stairs. The last one has an example of central tendency is a little bit different. Can you see the central tendency here? The central tendency here is not the same as the stairs, because in the stairs we had continuous interval or ratio, if you're talking about how many inches to the left or right they could stand. But this is nominal. This doesn't have any order to it. Each brand of beverage is its own nominal category. So in this case, the measure of central tendency would just be like there's more Pepsis than anything else. All right, so I'll talk a little bit about that if you can make it to class, but oh, I forgot I zoomed in on that. All right. Well, the shape matters, and the shape matters because the measure of central tendency that you choose as a statistician is going to depend on the shape. If you look at this, look at how a perfectly normal curve has three measures of central tendency that are all the same. The mean, median, and mode here are all the same. So in that case, you could choose any of those three measures and come up with the same answer. But look what happens with a positively skewed distribution. The mode is the measure of central tendency that has the highest frequency. It's right here. The median is all the way over here, and the mean is over here. what's happening is that when you have a skewed distribution, the mean is going to be pulled in that direction. And here, the mean is going to kind of exaggerate what a typical score is, whereas the median will give you a better score. Similarly, over here, the skew goes to the left, so the mean is going to be pulled to the left. And the mean will give you kind of a biased estimate of where the typical score is. Whereas the median tends to work a lot better here. So, those are the reasons why we need to know about the shapes of the distribution, because we want to use the shape in order to make decisions about what the most appropriate mean is. So, I think measuring central tendency is really easy. We're just going to run through a few examples. What I did is I just came up with 5 numbers to do this, just to make sure that you know how to calculate these. The first thing is the mean. The mean is just the average, and the average is something you probably learned to calculate in about 4th grade. We have the formula for the average is the sum of x, sigma x over n. Well, over here, the sigma x just means I'm going to add up everyone. That's 39 points. And the n is 5. 1, 2, 3, 4, 5. There's 5 people. And so if I look at the average, then 39 divided by 5 is 7.8. That's just the mean. This is going to be our favorite measure of central tendency. It's going to work well with central tendency for normal distributions. But as you recall, there are going to be situations in which the distribution is not normal, and we'll want to have a way of controlling for the mean, which tends to wander off in one direction in a skewed distribution. So in that case, we'll use median. And what I'm going to do is take each of these scores and put them in order. The lowest score here is 7, so I'm going to move that over here. The next one is 7. Okay, so I've got 2 7s, and as I go through this list, I have all 5 scores: 7, 7, 8, 8, 9. So they are in order, and then I find the midpoint. The midpoint is right there at 8, and so that means my median is 8. As you'll see in the book, you calculate that slightly differently if you have an odd or an even number. So let's say I had a 10 over here. My median would actually be the value between the 2 middle scores, and in this case that would be 8. Okay, one last thing, the mode. The mode is the most frequent number in the distribution. This is not a very helpful score in interval or ratio data, because in this case, you see there's not a most frequent number. There's 2 7s and 2 8s, and so they tie for the mode. So there's not really a mode in this case. That's actually why we wind up using the mode mostly just for nominal data. Okay, so let's see what we have left here. Which one do we use? Okay, so this brings it all together. We have the mean, the median, and mode, and it's up to us to decide which ones we're going to use. The way we do that is we start by identifying the scale of measurement in our sample. If that scale of measurement is nominal, then we'll use the mode. So remember, the mode just counts the most commonly observed highest frequency thing. When we identify the scale of measurement, if we get interval, or that should be a ratio, not ration. If it's interval or ratio, well, then we ask, is it normal? If it is normal, if it's not normal, then we would use the median, because as I showed you with that one slide with the skewed distribution, the median tends to stay in the center of the distribution when it's skewed, unlike the mean. And finally, I messed up that last one. Here, I'm going to just fix that one for you real fast. Yes, use the mean. There we go. All right, so that's basically how it works right there. You now know about the three main types of distributions we see. You know about the three measures of central tendency that we'll use, and you know how to match them up. Ultimately, we will almost always be working with normal distributions or things that are close enough to normal, and we will be using mean. So we'll be really used to those by the end of this term.